Massive news for gamers. A new GPUs maker just stepped into competition. Welcome to the Product Review Hub. Intel introduces Arc A series mobile graphics, providing powerful new options for creators and gamers. It's a watershed moment for Intel, which has been on a 4-year quest, or odyssey, to bring its first discrete consumer graphics chip to market in decades. Though Intel dabbled in discrete graphics a few years ago, today marks a more serious, well-funded entry into the market on what some may consider a duopoly of chief rivals NVIDIA and AMD. And while Intel is prepping a full barrage of discrete GPUs, graphics processing units, this year, based on its scalable Arc Alchemist architecture that can address strong desktop PCs to mobile workloads, the company is starting with a low-power laptop solution. And since this is a market category with a lot of volume demand and a great chance to enable the ecosystem with enticing new features, let's get started. The Intel Arc A series discrete mobile graphics are here to help. Desktop PCs, particularly gaming PCs, have substantially bigger power budgets, allowing them to throw significantly more processing resources at programs and workloads. Laptops, on the other hand, are significantly more power and thermally constrained, thus designers must be more inventive in order to bring new levels of performance and innovation to mobile platforms. And while introducing new innovation is clearly Intel's priority for this launch, let's first look at the hardware's nuts and bolts, speeds and feeds. There will be 3 Intel Arc mobile GPU families known as Intel Arc 3, 5 and 7, with the first Arc 3 available today, while OEM partners are just starting to bring machines to market. Arc 3 is the smallest, lowest power GPU in the Arc A series mobile graphics family, having 2 versions, while Arc 5 and Arc 7 will be larger, more powerful chips set to hit the market early this summer. This Arc graphics family has 2 base SoCs, system of chips, each with 5 GPU variants. The first 2 A350M and A370M GPUs will be powered by the Intel Arc Alchemist ACMG11 GPU architecture, which is a smaller, scaled-down version of the Intel Arc Alchemist GPU design. 3 higher-end Intel Arc 5 and 7 GPU solutions will be powered by a larger, full-flat ACMG10 Alchemist SoC, and as you can see, core counts and resources scale correspondingly. Intel has also unveiled the concept of an Arc render slice, which consists of up to 4 Arc Xe HPG graphics cores and 4 ray tracing units. For example, the ACMG11 version of the Arc A350M will have 1.5 render slices for a total of 6 Intel Xe HPG graphics cores, but the A370M will have 2 complete render slices for a total of 8 Xe cores and 8 ray tracing units. Intel will release the Arc 5 A550M mobile GPU, which has 4 render slices and 16 Xe cores, later this summer, probably in June, along with the flagship Arc 7 A730M and A770M mobile GPUs, which have 24 and 32 Xe cores and 6 and 8 render slices respectively. Ray tracing units, GDDR6 graphics memory, clock speeds, memory bandwidth, and graphics power consumption all scale as you can see. However, if we do the arithmetic, the most powerful Arc A770M GPU will be at least 4 to 5 times more powerful than the current Arc A350M and A370M GPUs. Beyond the Intel Arc Alchemist GPU architecture's Xe HPG cores for traditional DX12 Ultimate capable raster graphics and its ray tracing units, the Intel Arc Alchemist GPU architecture has a few more tricks up its sleeve, powered by AI accelerators and key proprietary system level optimizations that only an all-Intel platform can deliver. XMX matrix engines will be included in Arc GPUs according to Intel. These are dedicated matrix math operations processing engines that are heavily used in machine learning methods. These are specialized compute engines with additional new capabilities that enhance more than just gaming applications, similar to what NVIDIA calls its Tensor Core resources in GeForce RTX GPUs, though these are specialized compute engines with additional new capabilities that enhance more than just gaming applications. Despite having previously demonstrated its new XeSS Xe supersampling game upscaling technology, Intel used this launch to demonstrate the technology in live gameplay of the soon-to-be-released action role-playing game Dolmen, with lower resolution 1080p in-game settings but upscaled to 4K with XeSS. You can see what Intel's Arc graphics can produce. As you can see, there's a significant increase in visual fidelity when using Arc's XMX compute resources, with just around half the graphics workload of 1080p in game settings. This, according to Intel, enables for greater 4K equivalent visual quality while maintaining the frame rate and performance of lesser resolution settings. However, XMX isn't just a one-trick pony. Intel's Arc XMX engines also include some amazing new video upscaling and denoising tools for content creators. As you can see, it increases visual integrity while also removing a significant amount of grain and noise from the clip. This processing task is generally reserved for the CPU in software or distributed across cores in a CPU and a GPU using OpenCL. However, Intel Arc Graphics XMX accelerates the workload to finish the processing with a 2x speedup in render time. Furthermore, Intel recently unveiled its Deep Link technology, which combines both inbuilt Intel Xe graphics engines and Arc graphics for considerable performance benefits in a variety of video creation tasks. Intel Arc introduces AV1 support as well as a new, more powerful CPU-GPU partnership in these new all-Intel laptop designs. Intel Deep Link technology is a trio of acceleration approaches centered on simultaneous CPU and GPU utilization. Intel appears to be claiming a large performance boost of up to 30% as a result of dynamically balancing CPU and GPU power usage on the fly, which is something we've seen before from the likes of NVIDIA and AMD. This is done by power share based on workload needs acquired via telemetry by the Deep Link engine and algorithm. Furthermore, Intel claims that its Deep Link, which uses XMX engines for its hyper-encode and hypercompute technologies, can speed up multimedia creation workloads from great program suites like Adobe Premiere, Handbrake, OBS, XSplit, Blackmagic Design, and Cyberlink by up to 60%. The acceleration with Arc A series GPUs, on the other hand, doesn't stop there. Intel also claims to have the first comprehensive AV1 video encode hardware acceleration engine in the industry. AV1 is a new open-source video encoding and compression standard that was created to replace VP9. AV1 is capable of producing higher quality video at compression levels comparable to H.265, for example, or equivalent quality video at even higher compression levels for a large reduction in data consumption via internet connections. Think Netflix and, of course, game streaming. Intel has released a new demo today that shows Elden Ring game streaming using the XSplit broadcaster. You can see that AV1 produces substantially improved image quality and detail at the base 5 Mbps bitrate, which is the relatively pitiful upload speed of some internet connections these days. And Intel Arc will totally offload that streaming duty to the GPU. A look at the gaming and content creation performance of the Arc A3 series. Let's take a look at some specific performance metrics Intel has released today for Arc A3 series GPUs while we're on the subject of workloads. Intel compares the gaming performance of the Arc A370M to the integrated Iris Xe graphics found on its newer Alder Lake 12th Gen Core CPUs. You might be wondering where the competitive comparison is here, but in discussions with the Intel graphics team, the goal was to show the gains over Intel's existing solutions for premium, thin and light laptops. Think the 3LB weight class, and then let the press and analyst community show the competitive view once the systems were in hand for testing. Regardless, the Arc 370M boasts 1080p 60 FPS performance in some of the most recent popular gaming titles, which is a significant improvement over integrated graphics. If we were to compare this to NVIDIA GeForce MX entry-level discrete graphics options, I'd say we're looking at faster than NVIDIA GeForce MX entry-level discrete graphics capabilities here, but not GeForce RTX 3050 class firepower, at least for Arc 3 graphics. We may deduce from this that Arc A770M, Intel's top-end Arc mobile product, will be much quicker than Arc 370M. Intel was focused on delivering new innovations to market with this initial volley of its Arc A series graphics launch, not just for gamers, but for mainstream and professional content creators as well. As the new third alternative in the extremely competitive discrete graphics industry, it's exactly what the company needed to achieve. Intel would have been consigned to just another GPU offering without some of the critical differentiator features like Deep Link, AV1 support, XeSS, and Smooth Sync. This is a significant achievement in and of itself, but Intel was clearly listening to the community and opted to concentrate on allowing new powerful features in the thin and light premium laptop segment. It's also clear that this fledgling Intel graphics team is committed to keeping involved with and helping the community. In reality, I was told that the team is attempting to provide graphics driver updates every 2 weeks, albeit this may result in monthly releases if game title updates cause the target to be missed at times. Regardless, while Arc 3 graphics is obviously Intel's entry-level discrete GPU offering, the firm is only getting started, and I'm looking forward to seeing what Arc 5 and 7 have in store for us this summer. It was the proper plan to come out with a comprehensive list of software and acceleration breakthroughs like this early on. After that, there'll be bigger silicon and more firepower. In fact, a new player has joined the fray. Intel, bring it on! Thanks for watching this video. Make sure to hit like and subscribe to our channel.